All right, guys, today we are going to take a look at absolute value equations. So the first sentence is actually pretty easy. An absolute value equation is an equation that contains, you probably guessed it, an absolute value. So before we go any further, let's do a quick review of what absolute value is. Remember, absolute value is the distance that a number is from 0 on the number line. And distance is always positive, therefore absolute value is always positive. So if I asked for the absolute value of 13, that would be 13. If I asked for the absolute value of negative 13, that would also be positive 13, because both 13 and negative 13 are both 13 spaces from 0 on the number line. All right, so when we solve these equations, we're actually going to have two solutions to each equation. So think about this first one. It asks for the absolute value of x equals 7. In other words, we're trying to figure out what could x be that when you take the absolute value of it, you get 7. Well, the answer is x could be 7 or x could be negative 7, because think about it. 7, the absolute value of 7 is 7, because 7 is 7 places from 0. The absolute value of negative 7 is also positive 7, because negative 7 is also 7 places from 0. Let's try another one. The absolute value of x equals 3. Okay, well, x could be 3, because the absolute value of 3 is 3, or x could be negative 3, because the absolute value of negative 3 is also 3. We will be doing check steps on these. These initial ones are kind of simple, but again, as I just said, the absolute value of 3 is 3. The absolute value of negative 3 is also 3. So both of those come out true. Okay, so that's what we do if only the variable, if x is the only thing in the absolute value bars. But obviously we know there could be more inside those absolute value bars. And so that's what this box says, that the equation where if inside the absolute value bars we have several things going on, like ax plus b, for example, and we know c is greater than 0, we'll get into that more in just a minute, then we know what's inside that ax plus b could equal c, or what's inside the absolute value bars could equal negative c. So let's try this with a little bit more of a complicated problem. All right, so this time inside the absolute value bars, we have the absolute value of x minus 3. So we know that x minus 3 could equal 8, or if that x minus 3 came out equaling negative 8, this would still work, because then you're taking the absolute value, and the absolute value of negative 8 is also positive 8. So now we need to solve each of these. Over here, I add 3 to both sides, and I get x equals 11. That's one solution. Over here, I add 3 to each side, and I get x equals negative 5. That's the second solution. It doesn't have to be the positive and negative of the same number. That's just if that was how it was in the initial examples, because x was the only thing in there. But now we have more than x in there. So let's go ahead and check these. And because there's two solutions, there will be two check steps. So here we have the absolute value, and I'm going to plug in 11. So 11 minus 3 equals 8. Well, 11 minus 3 is 8. And the absolute value of 8 is 8. So that side worked. Now let's do the other one. We have the absolute value of negative 5 minus 3 equals 8. I'm plugging in negative 5 this time. Well, negative 5 plus negative 3 is negative 8. But the absolute value of negative 8 is also positive 8. So both of those solutions worked. All right, so now in example 3, it's getting a little bit trickier, because now we not only have the absolute value bars, but we also have some things happening outside of the absolute value bars. Okay, so before we can split this into two equations, we have to isolate the absolute value bars. before we can split it into two equations, we have to get the absolute value bars by themselves. So let's start doing that. The other thing I want to make sure to note here is we cannot distribute this 3 because the 3 is not inside the absolute value bars, and you can't take things in and out of the absolute value bars. So you might be tempted to distribute that 3, but you cannot. The first thing I'm going to do here is add 5. So now I have 3 times the absolute value of 2x minus 7 equals 9. So the next step is I'm going to divide by 3, because again, my initial goal is I'm trying to get those absolute value bars by themselves. And now I successfully have. I have that the absolute value of 2x minus 7 equals 3. As soon as your absolute value bars are by themselves, this is when you split the equation. Because now I know that what's inside there, that 2x minus 7 could equal 3, or what's inside there, this 2x minus 7 could equal negative 3. Notice when I split, I don't have the absolute value. I'm just taking what's inside those absolute value bars, that 2x minus 7. So I'm just pulling out what's inside and saying that it could equal 3 or it could equal negative 3. Okay, now on each side, I'm going to solve it the same way because I'm adding 7 and dividing by 2, but I'm going to get different answers. So here I get 2x equals 10. I divide each side by 2, and one solution is that x equals 5. Over here, I'm going to do the same thing because of that negative, though. I'm going to get a different answer. So now I have 2x equals 4. Divide each side by 2, and here x equals positive 2. You'll notice that your two solutions, it doesn't have to be that like one's positive and one's negative. So don't think that has to be the case. Okay, now we're ready to check. I've kind of run out of room, so I'm going to come up here for my first check and then down below for the second. Okay, so here I have 3 times 2, and then I'm going to plug in 5 first. Minus 7 minus 5 equals 4. Now, remember, the absolute value bars are a grouping symbol, which means you have to do what's inside of them first. So 2 times 5 is 10, and 10 minus 7 is 3. Then you have to take the absolute value. So the absolute value of 3 is 3. And then you do everything on the outside. So 3 times 3 is 9. 9 minus 5 is 4. So that one worked out for me. Now let's check your second solution here. So same thing. I have 3 times the absolute value, but this time I'm going to plug in 2. All right, I work inside the absolute values bars first. So 2 times 2 is 4, minus 7 is negative 3. Then I take the absolute value, and the absolute value of negative 3 is positive 3. And so now this last step is the same. 3 times 3 is 9. 9 minus 5 is 4. So you see that both of those solutions worked. Again, for each of these, there will be 2 solutions. All right, let's try a few more. Number 4. Well, you'll notice that on number 4, right away, my absolute value bars are by themselves. So this problem is even easier than the one we just did because I don't need to do anything else. I can split right away because the absolute value bars are alone. So r minus 7 could be 9, or r minus 7 could be negative 9. Over here, when I add 7 to each side, I get that r could be 16. Over here, when I add 7 to each side, I get that r could be negative 2. All right, now I'm ready to check. So here I have that the absolute value of 16 minus 7 is 9. Well, 16 minus 7 is 9, and the absolute value of 9 is 9. So that worked. Over here on the other side, I'm going to plug in negative 2. So I have negative 2 minus 7, which it might be helpful for you to keep change. So I get the absolute value of negative 9. But the absolute value of negative 9 is also 9. So that one worked as well. All right, let's go ahead and skip 5 and go down to 6, and let's try this one together. All right, as we start number 6, my first step is to get the absolute value part of the equation by itself. So to do that, I'm going to add 5 to each side to start. So that gives me 24. Then I'm going to divide by 4 on each side, and I get that the absolute value of t plus 9 equals 6. Now, the absolute value part of my equation is by itself, so I'm ready to split. And I know that what's inside there, t plus 9 could equal 6, or what's inside there, t plus 9 could equal negative 6. Over here, when I subtract 9 from each side, I get that t is negative 3, and that's one possible solution. Over here, when I subtract 9, I get that t could also be negative 15. So now I'm going to check both of those. Remember, when you check, go back to the beginning. So I have 4 times, and then in the absolute value bars, I'm going to first plug in negative 3. So negative 3 plus 9 minus 5 equals 19. So 4 times the absolute value of 6. Remember, work inside those absolute value bars first, then take the absolute value. So this would be 4 times 6 minus 5 equals 19. 4 times 6 is 24. 24 minus 5 is 19. So that one worked, which is great. I'm going to do the next check right down below here. So again, I start back at the beginning. This time I'm going to plug in negative 15. I work inside the absolute value bars first, so that gives me negative 6. Then I take the absolute value, and the absolute value of negative 6 is positive 6. And then this last step is the same. 4 times 6 is 24. 24 minus 5 is 19. So we see that both of those worked. All right, why don't you pause the video right now and try number 7 and press play when you're ready to check. All right, so again, on this one, I first need to get the absolute value bars by itself. To do that, I divide by 5, then I split, and you should get that x equals 1 and x equals negative 13. And when you check those, you see that both of them work. All right, now there's one special situation that happens when we solve absolute value equations, and that's that some of them can have no solution. And it should sort of make sense which ones don't have a solution. Think about it. We know that an absolute value can never equal a negative. There's nothing that you can take the absolute value of that equals a negative number. And that's again because absolute value is the distance something is from 0, and distance can never be negative. So if you look at this first example, when you see this initial equation, you should, start solving it. Nothing should alarm you yet. I would try getting the absolute value bars by themselves, and I subtract 6 to do that. Then I have that the absolute value of 3x plus 5 equals negative 8. And here is where we have a problem, because our absolute value bars are by themselves, and we know that an absolute value can't equal a negative. Now, we didn't know that at the very beginning. You got to be careful. Just because we see a negative 2 there, we can't conclude anything yet because our absolute value bars aren't by themselves. But once your absolute value bars are by themselves, if that equals a negative number, there's nothing that can work because, again, there's no absolute value that can ever equal a negative number. And so your answer here would be no solution and therefore no check steps either. All right, let's practice that a little bit more down below. So on number 8, my first job is to get the absolute value bars by themselves. So to do that, I'm going to start by subtracting 4 from each side. Then I'm going to divide each side by 2. Now, my absolute value bars are by themselves. So this is normally in the problem where I would split, but I I have the absolute value bars by themselves, and yet it equals a negative number. And that can't happen. That never happens. So this is no solution. You don't need to split the problem. You don't need to do check steps. If your absolute value bar is by itself and it equals a negative, there is no solution. All right, now let's go on to 9. 9 is one that can get tricky. Some people make the mistake that right away they see the negative 10 and so they say no solution. But remember, you can't do that. You are not allowed to say if something has no solution until the absolute value bars are by themselves. So that's the first thing we need to do, is get these absolute value bars alone. So that gives me -3. Then I'm going to divide each side by -3, and what you're going to see happens is actually our absolute value bars equal a positive number. So this does have solutions. We can now split this into 2 equations. That n plus 2 could equal 1 or -1. On each side, I'm going to start by subtracting 2. So over here, n is -1. Over here, when you subtract 2, n is -3. So again, don't jump to the conclusion too quickly that something has no solution, because you can only determine if it's no solution or not once the absolute value bars are by themselves. So this one did have 2 solutions, so I can check it. I've got -1 plus 2 that I'm going to plug in first. Again, I do the absolute value bars first. So that gives me 1. And then the absolute value of 1 is 1. So then -3 times 1 is -3, minus 7 is -10. So that one worked out. I'm ready to check the second one here. So I've got -3 times the absolute value. This time I'm going to plug in -3. So again, absolute value bars first, that gives me -1. But the absolute value of -1 is +1. And so just like before, -3 times 1 is -3, minus 7 is -10. So that one worked as well. All right, so we're going to stop there. Hopefully you've got a good sense of how to solve these. Again, you first have to isolate the absolute value bar. Then if it equals a negative number, there's no solution. If it equals a positive number, you split it into 2 equations and continue solving. Have a great day.